Welcome to another exciting episode of Math Simplified. Today we're going to be looking at vectors and matrices. So before we get started with the examples, I just want to first explain to you what a vector is and then of course what a matrices is, or what a matrix is. So when you think about a vector, I want you to think about a list of numbers. So the numbers can either be organized either horizontally. For example, if I had 3, 2, 1, this right here is considered a vector. It is a list of numbers. So this we call a row. So whenever you see numbers that are organized horizontally in somewhat of a list, it is called a vector. And again, we typically call it a row. However, vectors can also be organized vertically as well. So say, for example, I had this, and I had this as my list, and I still had 3, 2, 1. This is also considered a vector as well, and this we call a column. So if you notice here, the columns are pretty much going down and our rows are going across, and this again is an example of a vector. Now let's turn our attention to matrices, and the singular is matrix, plural for matrix is matrices. So a matrices is just going to be pretty much an array of numbers. So instead of having my numbers in a list going horizontally or going vertically, in this case as a row or a column, I'm going to have an array of numbers. So say, for example, I still had my 3, 2, 1. I had my 3, 2, 1, and I can mix in a bunch of other numbers as well. So I can have 5, 8, 7, 6. So here you notice that instead of having just one row and one column, I have 1, 2, 3 rows, and now I also have 1, 2, 3 columns. So this right here is our matrix, and these two things are considered our vectors. So now we're going to look at how we add vectors, and of course the rules for adding, how we add matrices and the rules for adding matrices. Let's now turn our attention to this matrix. So here we have 3, 5, 1 going across. So this we denote as row 1. So I'm going to say R1 for row 1. And then we have 2, 8, -4. So that we denote as row 2. So I'm going to go ahead and write R2 here. We're also going to look at the numbers going down. Remember when I showed you what a vector was, you notice that vectors either come in rows or they come in columns. But of course, within a matrix, you're going to have numbers organized in an array. So we're going to have like an array of numbers, not just a list, but an array of numbers. So here, if you notice, we have 3, 2 going down. So this we call column 1. So I'm going to go ahead and put C1 for column 1. We have 5, 8 going down, so I'm going to call this C2 for column 2. And then I have 1, -4 going down as well. So I'm going to call this C3. So I'm going to write C3 representing column 3. So the good thing about matrix is that whenever you have a matrix, you can name your matrix. And so people can get an understanding of what your matrix actually look like, what the numbers are organized, or how the numbers are organized. So again, we have 2 rows and we have 3 columns, column 1, column 2, column 3. So in order for us to name this matrix, we first identify the number of rows that we have, followed by the number of columns that we have. And it's pretty simple, you're going to see. So we have 1, 2 row. So we just pretty much say we have 2 rows. And then of course we have 1, 2, 3 columns. So we write that we have 3 columns. And then of course we put a multiplication sign in the middle. And what this is saying is that we have a 2 by 3 matrix. So we have 1, 2 rows representing the 2 that we have here. And we have 1, 2, 3 columns representing the 3 columns that we have here. So again, we call it a 2 by 3 matrix, and we typically want to put the rows, which is here, before the column, which is there. All right, so now we're going to go ahead and find out how we add matrix. Now let's go ahead and take a look at these two matrices that I have here. Again, the first thing that we need to do is that we need to name the matrix, or pretty much write the order of our matrix. So again, we look at the rows, we look at the amounts of columns that we have. We have 1 row, 2 row, and then we have 1, 2, 3 columns. So of course, this is going to be a 2 by 3 matrix. Looking at this one, we can clearly see that we have 2 rows, and of course 2 by 1, 2, 3 columns. So again, it's a 2 by 3. And that is something that you need to understand, that whenever you're adding or subtracting matrix, you have to make sure that the orders of both matrix are the same. If, for example, I had a 2 by 3 and I had a 3 by 2 here, I would not be able to add or subtract the matrix. The order of the matrix has to always be the same. And when I say order, I mean they both have to be 2 by 3. Here you can see 2 by 3. Now we can actually add the different rows and the different columns. So when we're adding, this is what we're going to be doing. And I'm going to go ahead and erase the 2 by 3 here and then show you what it should look like when you actually add matrices. So of course, they should equal to, I'm going to go ahead and draw. We're going to end up with, of course, one matrix. So here we have row 1, row 2, we have row 1, row 2. So I'm going to go ahead and write row 1, row 2. This is also row 1. This is row 2. This is column 1, column 2, column 3. Column 1, column 2, column 3. So when we're adding matrix, we're going to make sure that we're adding row 1, column 1 with row 1, column 1 in the second matrix. And when we do row 1, column 2, we're also going to add row 1, column 2 together. And then of course, when we're adding again, when we have row 1, column 3, we're going to also add it to row 1, column 3. Likewise, when we have row 2, column 1, we're going to add that to row 2, column 1. When we have our 8 here, which is in row 2, column 2, we're going to add it to the 0, which is in row 2, column 2. And lastly, when we add our -4, we're going to add the number here, which is row 2, column 3, to row 2, column 3. So we're going to be adding the -4 to the -1. So let me go ahead and write that out so that you can see that clearly. So again, row 1, column 1, plus row 1, column 1. And then of course we have row 1, column 2, plus. Now as you can see, this is the way we add the rows and the columns of one matrix, the row and the column of the other matrix. And again, just to point out something, if you notice here, we have row 2, column 1. So this is row 2, column 1. So this is 2. And of course, we're adding that to row 2, which is -4, column 1. So you can see the pattern that I used to add the different numbers within our matrix. So now we can just go ahead and plug the numbers in and then finalize to get our answer. So let's do that really quickly to get the final answer. So again, we have row 1, column 1. We're adding that to row 1, column 1. So we have 3 plus -8. That will give us a -5. Now we're adding row 1, column 2. So again, row 1, column 2. So we have 5 plus 9. 9 plus 5, that is 14. So of course, we're going to end up with 14 here. We have row 1, column 3. So row 1, column 3, we're adding 1 to 7. And of course, 1 plus 7 gives us 8. So now moving on to row 2. Here we have row 2, column 1. So row 2, column 1, we're adding that to row 2, column 1 of the second matrix. So we have 2 plus -4, which gives us a -2. And then we have row 2, column 2. So row 2, column 2. And we're adding that to our row 2 plus column 2. So we have 8 plus 0. That gives us 8. And then lastly, we have our row 2, column 3 added to our row 2, column 3. So we have a -4 plus a -1. That gives us a -5. And of course, we are done. So if you notice, we started off with a 2 by 3 matrix, and we end up with a 2 rows by 3 columns. So we end up with a 2 by 3 matrix. So all this is saying is that whenever you add a 2 by 3 matrix to a 2 by 3 matrix, you will still end up with a 2 by 3 matrix. If you do it and you do not end up with the same matrix that you started off with, then you made an error, and you need to go back to check to make sure that you are adding the right columns with the right rows.